Hello and welcome to a video on torque. In this video I'll be explaining and defining torque, and in the next video I'll give you some practice questions to do. So torque is just defined as a rotational force in simple terms. So imagine this is a bar. It could be of anything, any material, wood, steel, concrete, and we have a fixed point here. Say it goes like this. It's like a hole. Whoops, did that wrong. Say it's like an axle that goes through there. So this is an axle here, and this is a force. Center of mass is here. Now torque is defined as tau is equal to the distance d times the force vector. And usually this vector is at 90 degrees to the distance. However, sometimes the force vector will be maybe in this direction, but all we want is this component of the force, the component that's at the 90 degrees to the distance vector. So this is torque here. Now torque has units of newtons, force times meters here. But don't be deceived, this is not work. Like a box being moved with a force times a certain distance, d. Work is joules, so work is equal to joules, which is equal to Newton meters. But this here is not this. Now, when we're doing questions with torque, we want to figure out if the material is rotating first. So we're gonna go sum of the torques is equal to force times distance. But if this is equal to 0, so it's not moving, we're just going to get 0 is equal to the sum of the torques. Here. This is what we start off with in all questions. It makes it very easy to figure out an answer if we know it's rotating, or if we don't know if it's rotating. So say we have another infinitely thin line here, and here's a fixed point, point P1. And we have a force here, F1. Now, by intuition, you should be able to tell this force here is trying to move the bar this direction. So, if we apply another force here, F2, this force will try and move this bar in this direction. So the torques, this will let this be a positive torque and this be a negative. And when we do this in a question, if the bar isn't moving, we'll go 0 is equal to force 2 minus force, sorry, not force, we will go torque 2 minus torque 1, which is equal to F2 times D minus F1 times F2 times D2. And once we get to this, it's very easy to answer the questions. If you're given this and you're said it's not rotating, you'll usually be given one of the forces and both distances, or both distances, or both forces and one distance. And then you can work out either a force or a distance. In conclusion, if we have a straight bar here, and we have a force here at 90 degrees to the bar, and we have a fixed point, P1, the torque will be equal to D1, the distance, times the force, 1, F1. And if we know this, this here is rotating, we can plug the numbers in and we'll get distance times force, which is Newton meters. And that will be our torque. However, if there is more forces included, we'll have to go do the sum of all the torques, which is equal to either 0 or force times distance. If it's 0, it's not rotating. But if it's force times distance, or if it's greater than 0, we know it must be rotating. In addition, sometimes we will need to expand the force vector, so we get torque, because this is a dot product and not just a times, is equal to the magnitude of the distance times the magnitude of the force, F1, times sine theta. If we go back up here, we draw another force in, say here. This is the distance. This is the angle theta. Right here. And that's all I've got for this video. In the next video, I will be completing some questions, and I hope it's of use to you.